Hi, my name is Ron Bose. On behalf of the BSidesSF San Francisco Capture the Flag team, which is Brandon, David, Nero, and myself, I just want to welcome you to BSides and to invite you to play the Capture the Flag challenge this year. This is our, I believe, 5th time running the Capture the Flag, and every year we have a great time and lots of easy, medium, and hard challenges. If you're interested in playing, click on the CTF link on the BSides homepage, then click on the scoreboard link here, and that will take you to our scoreboard where you can register an account. You can play by yourself, you can play with friends, you can find a team on Slack. Just join the BSides Slack and find the CTF channel, and feel free to find people to play with, to ask for help, do whatever you like. I'm going to give a very, very quick walkthrough of a challenge called Run Me. Run Me is what's called a shellcoding challenge, where you write shellcode, which is basically machine code, and you send it to us and we run it. So I have a little example here that I provide. If you paste that into your terminal, what you should see is hello world. What you'll actually see is hello world because I made some sort of mistake. If you're interested in figuring out what mistake I made, that might be fun to do because I honestly don't know what I did wrong there. Now, if you actually want to try this challenge, you can either play against our server using netcat right here, or you can run it locally using the run me binary. So you can see I've already got the run me here, so I'll just overwrite it. We're going to make it executable first. Now, obviously remember, if you're downloading code off the internet, you probably shouldn't run it on your actual machine. You should use a virtual machine or a sandbox environment of some sort. But if you do run it, what you're going to see is send me x64. I'm going to type in code, and it's going to crash because it turns out ASDF is not valid assembly code. What is valid assembly code, however, is a string XCC. If we disassemble XCC, you're going to see it's a 1-byte instruction int3, which is short for debug breakpoint. If we actually run that, we're going to see a debug breakpoint. This is the first thing I always do when running an exploit because I want to make sure it's actually running. If you're also running a debugger at the same time, this will pass control to the debugger and let you see the environment. The other thing I like doing is EBFE, which is short for jump 0. That means jump to yourself, jump to yourself, jump to yourself. This is an infinite loop. If you run that against run me, you're going to see it's going to infinite loop and take up 100% CPU for 10 seconds, at which point it automatically is killed. Please don't run this infinite loop against our infrastructure because that's going to waste 10 seconds of our CPU time, and that makes Google Cloud sad. Probably also makes our sponsors sad. Alright, so to actual useful stuff, you're going to need what's called a syscall. This I found by Googling Linux syscall x64. These are all the things you can do: read, write, open, close, etc. And what we're interested in is a syscall number, which goes into RAX, which is a variable, essentially, and RDI, which is the first argument. We're going to find syscall 60, which is also known as sysexit, and RDI will be the error code. So let's just do that now. We're going to remove the old payload I wrote. We're going to start a new payload, Vim. It's a 64-bit application. We're going to move RAX to 60, that's the syscall num. RDI would be 1337, that's the exit code. And then perform a syscall. If we compile that using NASM, which is short for the N assembler, I don't know what the N stands for. We can assemble it, and we'll see this assembles to about 12 bytes of shellcode. If we run me with that code, we're going to see nothing obvious happens because you need to strace it. strace or system trace tells you all the syscalls being made, including the exit. So this does the exit with 1337, which is the error code that we chose. Now, if we want to do a real exploit, we're going to need to do more than just exit. We're going to need to do a open to open the flag file, read, and write. I've already written an exploit for that called exploit.asm. Exploit.asm, as you can see, does an open, a read, a write, and then an exit just to be polite. So we're going to compile or assemble that and run that, and we're going to see that that does indeed print a real flag. If we strace this, we're going to see it opens, gets file handle 3, it reads, and it writes. That's all. If this doesn't work for you, make sure the file actually exists, and have a great day.